So number 99, y prime is equal to, here we have an exponential function, or at least a number, a real number being raised to some exponent. So the derivative of that is always the same thing, but also then, since the base is not e, we have to multiply by the ln of the base, but then we also have to multiply by the derivative of the sine of x, which is equal to the cosine of x. And that's it. Number 100, we're supposed to find the equation of the line normal to the curve, okay, at a point. So we just need to find y prime. That's our goal, is y prime. Since y isn't explicitly solved for in terms of x, we could solve for y here. It might become a bit of a mess. So I'm going to go ahead and take the derivative of both sides with respect to x. And when we do that, we get the derivative of the left side equaling the derivative of the right side. And the derivative of the left side is equal to, we have this 3, I'm going to start way over here to the left. We have a 3 multiplied by the derivative of the product. And the derivative of the product is the first function multiplied by the derivative of the second, which is 3y squared y prime, plus the second function, y cubed, multiplied by the derivative of the x squared, which is 2x. And then that left side is equal to the derivative of the right side, and the derivative of a constant is 0. And so if I distribute this 3 in combined terms that are alike, we have 9, so 3 times 3 is 9, and then we have our x squared, y squared, multiplied by y prime, plus 3 times 2 is 6x y cubed, and that's equal to 0. Now at this point, I'm going to go ahead and use the space underneath here, so we're just going to forget about that problem for a little while. And in the space below, I'm going to go ahead and finish up the problem. So we want the equation of the normal line. Okay, and the first thing we want to do is find out the slope of the tangent line at that point. We really don't know what the curve looks like, nor do we really care. All we really care about is that there's the point 2, -1, and we want to find the slope of the tangent line right there. Well, if we want to find the slope of the tangent line, you can see that y prime in here is dependent on not only x but also on y. So we're just going to take this equation and we're going to replace x with 2. So we get 9 times 2 squared multiplied by, we're going to replace y with -1, so that's just going to be 1. Y squared is 1. And then multiply by y prime, plus 6 times 2 is 12 times y cubed, that's -1, and that's equal to 0. So we're trying to still figure out what y prime is. So we have 4 times 9 is 36. We have 36 y prime minus 12 equals 0. So if we add 12 and divide by 36, we get y prime equals 1/3. And if y prime equals 1/3, that means that the slope looks something like that. The tangent line slope is 1/3. Well, the normal line slope then is the perpendicular line to this slope of 1/3 would have a slope of -3/1. So the slope of the normal line is -3, and therefore we can come up with our equation, because we have y minus y1, which is y minus -1, equals the slope of the normal line multiplied by x minus x1. And x1 is 2, y1 is -1, and there we have our equation of the normal line. Looks like I'm out of room here, so I'm going to go ahead and stop this video and pick it up in the next one.